Welcome to Session 1, Introduction to Excel 2016 Functions, Data Analysis for Managers, BUS 450. In this modern world and living with technology every day, business has to manage huge amounts of data. Technology makes it possible to collect large amounts of data and has given more people the power and responsibility to analyze data and make good decisions. Business analytics, also called data analytics, has become a driving force in business and is a very hot field of study today. This course will focus on the analysis of various data types using the functions of Excel 2016. Business analytics typically implies the analysis of very large data sets, and for this reason, the term big data has also become quite popular. Course content. This course will cover topics from two separate fields, statistics and management science, which actually go very well hand in hand. Statistics is a study of data analysis, and management science is the study of model building, optimization, and decision-making, often based on that data. Data analysis will include data description, data inference, and the search for relationships in data, while decision-making will include optimization techniques for problems with no uncertainty, decision analysis for problems with uncertainty, and structured sensitivity analysis. We will deal with uncertainty, including measuring uncertainty and modeling uncertainty explicitly within the course. Some of the features of Excel that we will be working with. The software included in new copies of this book, together with Microsoft Excel, will provide a powerful combination that can be used to analyze a wide variety of business problems. Excel is the most heavily used spreadsheet package on the market, and in this edition we will use Excel 2016. Some features will include the Solver add-in, which uses powerful algorithms to perform spreadsheet optimization, and the Solver table add-in, which will show you how the optimal solution changes when certain inputs change. These are the sorts of things that even 6 years ago we had to run using entirely different tools that were not nearly as user-friendly. Some additional features we will use are decision tool suites, which contain Excel add-ins, the at-risk, which can run multiple replications of a spreadsheet simulation, perform a sensitivity analysis, and generate random numbers from a variety of probability distributions, and risk optimizer, which combines optimization with simulation. We will also use Big Picture, a smart drawing add-in used to represent the elements and relationships in a model so that you can better visualize a problem. Some additional components of the Decision Tool suite includes Stat Tools, which generate statistical output quickly in an easily interpretable form, and Precision Tree, which is used to analyze decisions with uncertainty. The primary method for performing this type of analysis is to draw a decision tree, and this does this in a very clever, intuitive, and user-friendly way. We can calculate net present value, or NPV, with a spreadsheet. Spreadsheets are an excellent way to compute the NPV, especially when you have to compute the cash flows as well. So using the NPV function, the first component is the required return entered as a decimal, and the second component is the range of cash flows beginning with year 1. You will then subtract the initial investment after computing the NPV. Another measurement is IRR, or internal rate of return, and this is the most important alternative to NPV. It's often used in practice and is intuitively appealing because it's based entirely on estimated cash flows and is independent of interest rates that are found elsewhere. To calculate IRR with a spreadsheet, you start with the cash flows the same as you did for the NPV, and then you use the IRR function. So first you enter your range of cash flows beginning with your initial cash flow. You can enter a guess, but it's not necessary. The default format is a whole percent, and you'll normally want to increase the decimal places to at least 2 to have some more accuracy. Some management examples of the discounted cash flow criteria. Net present value, which is the difference between market value and cost. You take the project if the NPV is positive, has no serious problems, and is a preferred decision criterion. And IRR, which is a discount rate that makes NPV equal to 0. You take the project if the IRR is greater than the required return. The same decision as NPV with conventional cash flows. IRR is unreliable with non-conventional cash flows or mutually exclusive projects. And also the profitability index, which is the benefit to cost ratio. You would take the investment if the profitability index is greater than 1 and cannot be used to rank mutually exclusive projects. This tool may be used to rank projects in the presence of capital rationing. The most meaningful way to examine relationships between two categorical variables is with counts and corresponding charts of the counts. You can find counts of the categories either variables separately or as well as joint categories of the two variables. Corresponding percentages of totals and charts will help you tell a story. Here's an example. If our objective is to use a crosstabs to explore the relationship between smoking and drinking. The solution, dataset lists the smoking and drinking habits of 8,761 adults. Categories have been coded N, O, H, S, and D for non, occasional, heavy, smoker, and drinking. To create the crosstabs, enter the category headings in Excel and use the countifs function to fill the table with counts of joint categories. Next, you'll sum across rows and down columns to get totals and then express the counts as percentages of rows and percent of column. Thank you for listening to Session 1. You are more than welcome to share questions, concerns, comments, and so on in class.